Hi, I'm Peter. So before our lesson start, let me introduce a little bit about myself first, and then let me know more what is going on in our Department of Computing. So I'm Peter. I'm in charge of PolyU Game Lab. So if you are interested in our PolyU Game Lab, so you can go to Facebook or you can go to YouTube and then search for PolyU Computing Game Lab. Okay, PolyU and then COMP and then Game Lab. We have organized our game labs for more than 14 years, okay, for more than 14 years. So we create lots of games, and then most likely, if you have heard about PolyU Game Lab, definitely is in different competition because we have received lots of the award from different competition, including the Global Game Jam, including some of the competitions with the mainland, including the Microsoft Emergence Cup, okay. But around 5 to 6 years ago, our previous department head asked me, so what are you doing? So you have created some games and then no one's know you're creating some games, or as a result, we do not have create any impact in our market. So if you have heard about the computer games, so somehow the demand cost and also the advertisement cost is 50-50, okay, or more than 50 the advertisement cost. So for a global advertisement for a global games, right? So most likely is around 20 million US dollars. So definitely for a university, we cannot offer these kinds of advertisement. That's why we create games, and then some of the game we have received some award, and then we go to the ACG show, animations, comic, and game sold. But we do not receive any feedback, or in the market we seldom receive any feedback or any impact from the industry because no one knows our university grade games. So 5 to 6 years ago, I need to rethink because yeah, this is the request from our previous head, and I need to think. So what should we, what is our next step, and then what should we do in the future? So at that time, 5 to 6 years ago, no one wrote VR and AR, and this is a untapped area in games. And then because VR, AR, they need the game experience. So somehow they need computer graphics. So somehow they need some HCI, human computer interface. So somehow they need to deal with some new device. Okay, so we step into the VR and AR, and it's good, right? Because at that time no one knows how to use the VR and AR, and then we are quite mature to use this kind of technologies because from games, computer graphics, and other input device move to the VR and AR is pretty easy. So we receive different commercial jobs, okay, commercial job including Alibaba, including Sony, including HKO, etc., etc. Okay, but after 2 to 3 years, so we still find another problem. We receive some commercial job, we receive some industrial project, but somehow for lots of the industrial project, no one will remember PolyU. No one will remember Department of Com because they will be hidden from some big name, for example Sony, and then for example the HAO, for example the Alibaba. They will hidden from some big name. So we need to find another area that we can work for. So that's why we do for some underprivileged group, and then we do some service learning, and then we care about the children, we care about the elderly. We create some VR and AR application for some niche area for some underprivileged group, and that's why we create the impact. Okay, so if you want to have a look with more about our product or more about our interactive creation, you can just go to YouTube and then have a look with our channel, so you know what we are going on. Or if you want to create a game together with us, so somehow, of course, you can like our Facebook fans page, or every year we have the Global Game Jam. Okay, in the January we have the Global Game Jam. So I'm the host of Global Game Jam Hong Kong. So if you are interested in, you can still go to the Facebook and then search for the Global Game Jam Hong Kong, and then yeah, add us, and then yeah, you will know what's going on in our future. Okay. So today our topic is virtual reality and augmented reality development. VR and AR, so there are two different kinds of reality. VR means that virtual reality means that put you into a virtual world. For example, just like the games when you're playing the PlayStation VR or when you're playing the HTC Vive, right? So the main idea is immersive and isolation. So they isolate your visions and isolate your audios. So it's similar to teleport or send you to a virtual world, and then inside this virtual world, you cannot see any physical object. Okay, you cannot see any physical object, even your hands or your body. We will use another virtual object to replace. So you will see some virtual hands or virtual controller inside the VR or inside the VR games that you have experienced before. AR, augmented reality, is different. So augmented reality, AR, means that put the virtual object into the physical world. Okay, put the virtual object into the physical world. So in sense of augmented, in sense of put more information in your physical world. So lots of the AR, the AR experience is somehow you use your camera. So they are still capturing the physical world. Okay, and then they are putting some virtual object into this physical world. For example, if you are using the Go Map, so they put some test label into this physical world. So if you are playing the Pokemon Go, so inside the AR environment, so they are putting some virtual object, virtual Pokemon into the physical world on your floor or on your table. So the main difference between VR and AR is their focus are different. Okay, their major components are different. VR is put you into the virtual world, and then AR is put the virtual object into the real world. Okay, of course, it's hard to define the VR and AR nowadays because there are some applications or there are some games they mix with each other. Okay, so they combine the VR and AR together. So today we use another new terms called mixed reality. Some of them they are saying that MR, mixed reality. Some of them they put the X into it, so it's XR. Whatever is MR or XR, it means that we try to blend the virtual reality and we try to combine the virtual and augmented reality together into a new environment. And today, lots of the hardware they start to support these kinds of applications. So when you buy the VR device, and then you find there are two cameras in the front of the head-mount display, that means that they are ready for AR also. They are ready for mixed reality also. Okay. So we will start with the virtual reality first and then augmented reality. For the virtual reality, we will divide them into first, we will have the general view of the virtual reality. So what is the keywords, what is the key component in virtual reality? And then we'll go to the hardware. So when we go to the hardware, we will divide them into output and also the input. Okay, we have output device and input device in the virtual reality. So we'll discuss them one by one. And then we will discuss the type of the type of the hardware, because you have different input and output device, so how they combine together and then become a VR device, and you will find available in our market. So we will discuss some of the VR device in the market and then how they give you different VR experience. Okay. Then we'll go to the software of the VR. So we will briefly discuss how the computer graphics they are operate inside the virtual reality, and then what is the key or core elements inside the software. After that, we will go to the AR. So we have similar defines like that. So virtual reality, so as we have discussed before, virtual reality is put the user into a virtual world. Okay, put the user into a virtual world. That means they want to isolate and immersive. Okay, create immersive simulations. Okay, so when you are create the VR project, so definitely you need to think two keywords. The first one is immersive. Okay, another one is realistic. We'll discuss them later. For the immersive, means that you want to isolate the user from the physical world. So the user, when they are moving their head, they will not see the physical world. They will only see the virtual world. Okay. And then realistic most likely is referred to the computer graphics and also refer to the physics. Okay, we will discuss later. So how we can get the user feels more realistic inside our virtual reality world. So if you think that the virtual reality will start in this 5 or 6 years, I will say that the virtual reality begin or similar when the computer starts. So the first VR machine start in the 1950. Okay, in the 1950, that means 70 years ago, similar to the mainframe, similar to our first commercial machine. Okay, commercial mainframe computer. So the situation is like that. You put your head inside this camera, and then the camera inside this machine, and then all the projection here we will divide into left and also right. The situation why the virtual reality becomes very famous today, or it becomes a hot topic today, is because we put lots of the money into our mobile device, okay, into our smartphones. So when I'm still an university student, is around year 2000, right? So most likely when I spend on a mobile device, only 1,000 something. Okay, it's only 1,000 something, and then I get a smartphone, and then I will use it. But for the computer, I will spend more than 20,000. Okay, I will spend more than 20,000. But today the situation is a little bit complicated. So most of the people, they will spend a lot in their mobile device. So most likely each year you will spend 5,000 or nearly 10,000 for each year. But for the computer device, perhaps you will only spend 10,000 or 15,000, and then you haven't changed for a long time because you think that yeah, I will have enough computation power for my daily work. Okay, so why I need to change my PC? But for the mobile device, you always change. Okay, because you invest a lot in your mobile device, and today the computation power of your mobile device is exponentially increased. It's similar to a PC. So most of the people, they do not have a PC at home, but they will have some powerful mobile phone, because when they go back to home, they can handle all the office work, or they can still playing games inside their mobile phone. So that's the situation nowadays, because you invest a lot. So the company, they can put lots of different sensor and computation power into your mobile device, and it is easy to change our mobile device into head-mount display. Okay, into different kinds of HMD, head-mount display here. Yes, head-mount display. Okay. Your mobile computer have enough resources, whatever is computation power or whatever sensor, they have enough resources to run the virtual reality. Okay. So it's easy for them to separate the screen into two, and then it's easy for them to capture your input, the movement of your head or the movement of your hands, and then change it into the input of the virtual device, and then generate the computer graphics within a very short time. Okay. But in fact, the virtual reality is not only present in the head-mount display. You can also present the virtual reality in the computer monitor, or in a projection screen. Okay, so we'll discuss this kind of settings later. So same as the other computer device, or same as the situation that we have learned before in HCI, human-computer interface. So the VR system, we also have the input, process, and also the output. For the input device, traditionally we have the keyboard and mouse input, right? But today we can have lots of different kinds of input device. So you will use the gamepad, or you will use the joystick, or you will use some contactless. Okay, contactless device to capture the input of your hand. Of course, today you also have the head-mount display. Head-mount display is not only head-mount display is not only for the output. It's also used for capture your inputs of your head. That means your orientations of your head. Okay, so it's also a input device for you to capture the inputs of your head and then to the VR system. We can also use the microphone. Okay, so we can use the speech to recognize your speech and then change it into some keywords and then match these keywords into our logics of the VR applications. Okay, so those are the inputs. So after you have captured the input, and then you will have a kind of software to handle software and also the hardware to handle the process. Okay, so for the hardware, it's easy to understand. We can divide all of them. We can divide all of the process into 3 files: CPU, GPU, and also PPU. Okay, CPU, I guess all of you guys know the situations, right? So CPU and then the GPU is common in the computer device. Okay, CPU is mainly for the logic and also for the input and output. Okay, also for the I/O. Okay, so for the CPU, so if you have lots of the programming logics or you have lots of the calculations, okay, logic calculations, so most likely is handled by the CPU. Okay, most likely is handled by the CPU. For the GPU, graphical processing unit, okay, so it's used to calculate the 3D graphics, 3D computer graphics, because for the 3D applications or 3D computer graphics, there are lots of vectors. Okay, there are lots of vectors, there are lots of matrices, and then there are lots of calculations of complex number. Today, don't think that your computer world they are using the 3-dimensional to calculate. So most likely we are using quaternion. So it's kind of six dimensional. So beside the XYZ, XYZ, so you have also the IJK. So if I remember, in my secondary school, we have learned what is the situations of complex number, right? Complex number I. So complex number I means that for the real world, if we are using the 3-dimensional things, you are using the mathematics of Newton. It cannot completely represent the situation in our world. Okay, so that's why we have the quaternions, and then that's why we have advanced physics to learn about it. In computer world, the situation is similar. So if we are using XYZ 3-dimensional to calculate all the computer graphics, it's not enough. Okay, it's not enough. And then we need to project the problems into higher dimension to solve. Okay, that's why we use the complex number. In our secondary school, we only learn about I, right? So you have the real part and then imaginary part I, right? So now we are in our computer graphics, we are not using I only, so we are using IJK. Okay, so beside the XYZ, we have another 3 dimensions called IJK to represent the transformations in the 3D environment. So you need to know about that. Not only the physical world, they use the higher dimensional. Also in our computer world, also in our game developments, in VR developments, we also use these kinds of calculations. Okay, this kind of high dimensional calculation. And then because we use matrix, we use the vector, and then we use the complex number, we have lots of the floating point calculations. Okay, we have lots of the floating calculations, and this kind of floating point calculation cannot be easily or fast or handled by CPU in an efficiency way. Okay, so that's why we need GPU. Okay, so GPU is for the floating point. Floating point in our game development is for the vector, matrix, and also the complex number calculations. Okay, so this is how we are using the GPU in our computer graphics. Okay, and another thing is called GPU. So and beside the GPU, another thing is called the PPU, physical processing unit. So as I have mentioned before, for the VR, there are 2 keywords for the VR applications. So the first one is immersive. Okay, immersive. So we use the input and output and then give them the immersive situation. So we isolate the user from the real physical world. So another keyword is realistic. So realistic not only for the GPU, not only for the computer graphics, it's also for our physical calculations. That means all the Newton's law, or we will say that's all the calculations of complex number. Okay, so PPU is dedicated to calculate all the physical simulations. Okay, all the physical simulations. Maybe you need to calculate the Newton first, second, and third law. You also need to calculate lots of the things about the particle simulation, for example, the wave, okay, the water, the wave, or the sunshine, etc. So those of the things is our physical world simulations is handled by the PPU. So today, if you want to get a perfect experience for the VR. Okay, so not only the GPU, sometimes you also need the PPU, physical processing unit, to handle it. Okay, so this is the processing part, and then beside the processing unit, you also need the RAM. Okay, you also need the RAM. So if your application is full of logic, for example, you are playing some RTS game, real-time strategy games, and then there are lots of the logic inside your games. So the situations cannot handle lots inside your GPU, so you need lots of the RAM. Okay, memory to handle it. Okay, so if your 3D application, you have lots of high definition texture. Okay, high definition texture. That means the PNG or TIFF or somehow about the PNG, etc. Right? So they are not the vector. They are not the vertex. They are 2D image. Okay, so if you have lots of the texture and then lots of the beautiful texture in your game, so you need video RAMs, okay, video RAM inside your GPU. Okay, of course, if your calculations inside here, you have lots of the physical. For example, you need to simulate the particle, you need to simulate the wave or a very beautiful reflections, right? You need to store the data inside your hardware. You also need the RAM, okay, to handle the memory of your system. So in short, to summarize this kind of situation, so this kind of process, so if you are going to separate, so CPU is for the thinking, okay, CPU is for the thinking, GPU is for the rendering, and then PPU is for the interact, okay, it's for the interact. So they separate the word, and then because you have a dedicated hardware, dedicated formula inside this processing unit, dedicated formula inside this processing unit, right? So your processing power will be exponentially increased. So why we need to exponentially increase our computation power? So we will go to the output part. Okay, go to the output part. So for the traditional outputs of a computer games or a VR equation, so most likely we'll use the HT, and then upgrade frequency is only 60 Hertz. Okay, it's only 60 Hertz. Okay. But for the VR device, so if you are asking for some non-dipsy, right? You don't want the user to feel dipsy, right? And then you want the filter to feel it's real. So we need a higher refresh rate, okay? So most of the VR applications, they are request more than 90, okay? More than 90 Hertz to refresh the screen. So now the situation is you have one screen for 60 Hertz of our traditional VR application or traditional games. But for the VR, at least you need 90 for two, the left eyes and then the right eyes. Okay, so you need two screens, and their refresh rate is at least 90. So you need to push the hardware limit into a higher computational power to achieve this kind of situations. Okay, so that's why we want to separate our word, and then that's why we want to put the formula of the graphical processing unit and also the physical processing unit. We want to put this kind of formula into the GPU and PPU to separate the words from the CPU. Okay, so we have a better performance, and then we can refresh the application, refresh the screen in a higher and higher rate. Okay, of course, for the output, we can also output the audios. Okay, we can also output the audios to the headphones, and also the speaker. We can output the vibration haptics controls to the gamepad. So a lot of the controller, for example, if you are playing HTC Vive or you are playing the PlayStation VR, so you will select the vibrations. Okay, you will simulate the haptics. Okay. So if you have chance to come back to our lab, all of our machine inside our lab, not only in our VR lab, we are using the Titan, but for all of our machines inside our computing lab, general computing lab, we are using GTX, okay, 1080 Ti or above, okay, or above. So hopes that sooner or later you have the chance to come back and then taste the, we give lots of the resources in our computer, and then hopes that you can enjoy it later. So beside the hardware, and then you also need the software. Okay, so for the software, at least you need a OS level. Okay, because for the VR application, you are handling the computer graphics, and then there are lots of different OS, and then for different OS, you need different kinds of rendering. Okay, you need different kinds of HAL, hardware abstract layer, to handle the communication between the hardware and also the communication between the application. So you have heard that you have the Direct, okay, in Microsoft solutions, or you have the OpenGL in the Linux or in the Apple solutions, okay. So inside here, we will write our application. So we have the middleware, okay, for the HAL, and then we'll write our application for the games, okay, for other VR application. And this one is the input and output loop. So for this kinds of loop, at least it's 90. Again, at least it's 90, okay, 90 hertz. So you need to refresh your screen within 1/90 seconds, okay. So it's the situations of VR applications in 2014, okay? So 2014 and 2015. So after 5 to 6 years ago, the situation is more or less the same, okay? So let me explain this graph. So for the easy understanding, so this one is, okay, grouped by the age, okay? So you have the 10 years old, you have the 20 years old, and then you also have the 30 years old, okay? And here is grouped by the topic. So you have RPG, roleplay, and then you also have the FPS, etc. and etc. So you can easily find that most of the VR applications is fall into game, okay, is fall into them. So that's why there are lots of the VR applications here is about the FPS game for the 20 to 30 years old, okay, for the 20 to 30 years old. And then there are lots of sport, okay, sport game for them, okay, for the teenager. Okay, of course, you have some fighting, and then also different kind of situations for the 20 years old to 30 years old guys. Okay, so they somehow they are rich, so they go out to work. They can go out to work and then earn for their living, so they can buy the VR device and then pay for it. So there are lots of people focus on this market. Okay, focus on this market. Okay, it's easy to understand. But it's our approach, right? So we have talked about our approach. So we would like to do something for some underprivileged group. So the reason besides that we do something for underprivileged group or for some niche area is that if you focus on the FPS game, or if you focus on the sport or some speed, fighting, etc., this kind of VR, so it's really hard to compare our applications to the big parties. Okay, the big they have lots of the investment, and then they can do something really good. Okay, they have realistic rendering, because for computer graphics or for game developers, so the money that you invest in the graphics, okay, is the how details is your game, and then how beautiful is your game, how realistic is your game. So definitely it's not our approach. So somehow you can think about this kinds of empty area, okay. For all the empty area, you can think about it, and also this is our approach, okay. So that's why we create the applications for the youngest, okay, maybe 10 or 20 years old, for some special education need, or for some children that they have learning disability, okay, they have learning disability. But somehow you think that some of my advice is a little bit stupid, right? Can you see that this one is adult film, okay, adult film, and then you say that how can we create the VR applications for the children, okay, for the children who is 10 or 20, right? Here is empty, we do not have any application for them. But if you think that create this kind of VR application is difficult, so try to emerge about sex educations, okay, sex educations. When I'm in primary school or even I'm secondary school, so it's quite hard for the teacher to teach the sex educations, right? Yeah, we are quite embarrassed. And then except remember my primary school teacher when I'm in the primary 6, she was a girl, she is a female teacher, right? she's red, okay? She's red, and then she feel really embarrassed when he's going to talk about the sex education with us. So try to imagine if you put it into our education, and then if you create some sex education for our teenager, okay, for our teenager, so definitely you can solve this kind of embarrasses, okay? So not only about the teacher, it's also about your classmate. Try to imagine all of you guys when you are looking at the teacher and then he or she is talking about sexual education, you also look at your classmate, right? And then the situation is really, really embarrassed. And then if you put the VR application in it, and then you are isolated from such kinds of embarrassed, okay, such kind of situation. So it is worth, okay, it's good to disrupt, okay. So as I have mentioned before in our previous slide in 2018, okay, 2018, the situation is more or less similar. So most of the VR application, they are focused on games or entertainment, okay, games or entertainment. So nearly 65% are handled in it, okay. I'm not saying that this wrong, okay, because you have this kind of needs, and then puts the VR into games or entertainment is the fastest way to driven the VR industry development, okay, development of the VR industry. And lots of the people, they buy this kind of products, and then lots of the people, they buy the products to enjoy the special feelings about the virtual world, okay. But if you are a small company, and then of course if you are a education university, right, you cannot spend lots of the money for these kinds of developments. So you can focus on some niche area, okay, niche area. For example, I'm here, okay, I focus on educations, and then I focus on some education for special education need, okay. For example, the dyslexia, for example, the profound and multiple learning disabled children, okay. So here you can still think lots of interesting idea for the virtual reality, okay. Because I will say that another idea. So lots of the people during the COVID-19, so they feel they try to do the VR for the attractions, okay. So they create a VR tour, and then you can go to anywhere, okay, to experience the feelings of the situation in another world, okay. So this is some of the topic you can do for your VR development or for your VR industry. So most likely when we start the VR topic, so most likely we'll start about with this graph, okay. So here you have the goal, and you have the start, sorry, you have the start, and then you have goal. So I will give you 1 minute to find the shortest path from the start to the goal, okay. 1 minute. So time's up. Okay, I'm sorry that it's a virtual it's a PowerPoint, so I cannot print it out. So lots of the people will try to say that the shortest path will be here. Okay. Okay. I don't know if it's correct or not. Perhaps you can find another shortest path to in this match by traveling a correct solutions inside the match, right? But it's quite time consuming. It cannot be handled within 1 minute. And when I present these questions to lots of the audience, so most likely they are higher educated people, okay, higher educated people. So they are university student, or they are master student, or even they are professional, they are expert in different area, okay. So I will say that they are familiar with the paperwork. Okay, they love readings. Okay, because throughout our exam system, so if you love readings, okay, if you love handle the wording, handle the 2D, okay, 2D situations, so definitely you will get a high grade in your educations, and then you can go to university, or you can have a higher positions in our world. Okay, but for these questions, if you want to find the shortest path, if it's a print out, okay, to print out, so the shortest path will be you fold this paper, okay, and then when the start point and then the goal become one point, okay, become one point. So if you print the paper and then you fold it, so the start and then the goals become the one point, okay, so they are meshed together. So this is the shortest path. I present this idea because lots of us, because we are highly educated, so we are familiar with the 2D world. So we forget we are 3D animals, okay? We are living in a physical world which is 3-dimensional, okay? So we can play with the spade, okay? We can play with the spade, and then we need to alert that all the things is not only from the paper. We can do it in a physical way, in a 3-dimensional way, okay? So another example to have a better understanding about why we need to VR. So there are two examples. One is from biology, okay? One is from biology, another is from the math, okay? So if you think that this one, 2D image, okay, and this one, 2D image of the map is easy to understand, so definitely you are suitable for the higher education, okay, because most of our higher education is 2D world, okay, it's 2D wording, 2D graphics, and then such kind of 2D graphic is abstract, okay, it's abstract, so it's less information in one paper to represent all of the ideas, okay, so it's quite abstract. So if you love this kind of abstract, then that means that you love abstract thinking. Okay, that means that you are suitable for the higher education. But try to remember, there are lots of the people. Their IQ are normal. Okay, their IQ are normal, but somehow they just hate. They just hate the 2D information. They really want something can be visualized in their physical world or visualized in their 3D world. That's why some of the people they love these applications, okay, HoloLens. So this one is HoloLens, and then you see different kinds of virtual model, and then appearing in the physical world, and then you can touch, you can change your hand, and then have a look with different kinds of situations, and then it's really realistic, right? Or you will love this kind of the Google AR map, okay, Google AR map. It project all the tasks, the overlay all the tests or all the information that you need into the physical, okay, into the physical world. This kind of applications, for example, this kind of application or this kind of applications, the advantage is you need not to learn, okay, you need not to learn. It's really natural. It's very natural. It's suitable for all the peoples, okay. So yeah, visualization in 3-dimensional allows more easy and more human to understand, to see the patterns, the relationship, and the trends. Okay, so if your application is going to give to, for example, the professor, okay, to professor in the university, or you want to give this kind of application to some people who is high educated, definitely you need not to present it in a virtual reality way, or you need not to present in a game way. You just give them a 2D paper, okay, 2D paper, even the wordings, okay, even the wording, they really love the wordings, so they read the wordings, and then they can emerge, and they can have lots of abstract thinking, okay. You need not to prepare any different virtual reality for them, okay. So for the VR applications, before you start your development, always ask 5 questions, okay, always ask 5 questions. The first one is why I need a 3D working space, okay, for these applications. So if your audience, okay, if your target audience is professor, okay, again, it's professor, teacher, and then the others people who are familiar with the 2D. So why you need a 3D working space for these applications? If it can be well presented in 2D environment, and then it can fully accepted by your target audience. So you need not to have any 3D space for it, okay? So another one, why you need immersive environment? Why you need an immersive environment? Okay, because for all the VR application, you are isolated from the physical world. So you are isolated from the things that you can play, right? Just like now. So the difference between we are using the Zoom meetings or between we are using the VR, right? If I put all the PowerPoint slide in the VR application, the one and the only one reason that is I want you to focus. Okay, I don't want you to page with your mobile phones. I don't want you to page with the other stuff during our teaching and learning. Okay, so immersive isolations give you this kind of chance, and then you need to ask why the people need these kinds of isolations and immersive environments. Okay, in these applications. And other things, why do the people need the motion sensing in these applications? So I will explain it later, because for more input data that you give to the VR application, you need a higher computation power to handle. Okay, so for example, for the Google Cardboard, right? Google Cardboard, the Google Cardboard only handle the orientations of your head. Okay, of your head. For the HTC 5, so they handle the movement of your head, they handle the position of your head, they handle the hand movement. Okay, if you pay for more, for example, motion capture system, you handle lots of the position and also orientation of the different parts of your body. So if you increase the number of input, it will exponentially increase your computation power. Okay, and then your VR application will become it's become more difficult to develop, and then it costs you more and more money to do it. Okay, so these are the three major questions you want to ask, and then always remember to do different kinds of background study. Okay, different kinds of background study. So does it exist already in the market? Because we have for the VR developments, it's become a hot topic in these 5 or 6 years. There are lots of applications. So if you want to do a VR application, go to the market, go to HTC 5, go to Steam, go to the Oculus Rift to find is there any similar. Okay, is there any similar applications in the world? Okay, in the world. So have a look, and then if you can use it, just use it first. Okay, because creating a VR application is more or less quite expensive. So it's more or less similar to 500,000 to 600,000 for one application if it is complete. Okay, so try to find some VR application whether it can fulfill your needs or not. Okay, if you think it's not good because you have to do the background study, so somehow you can point out their winners and then improve in your next version. So always do the background study first. Another thing is why us. Okay, for the VR application, you need 3 different kinds of people together and then to create your VR application. The first one, of course, the programmer, the technicians. Okay, so you need someone to write the logic, you need someone to handle the input and output device, etc. Right? And other one is you need another group of people to handle graphics. So you need the 3D designer, 3D tester, you need the people to create the 3D scenes, and then all of it is counted by the money. Okay. And then the third one is the domain expert. So just like us, when we create lots of the VR applications, so we need the other expert. For example, the expert in SEN, okay, SEND, special education, the expert in dyslexia, the expert in elderly therapy, etc. Okay, so 3 different kind of people together so that we have the chance to create the VR applications. So some criteria about the HCI. Okay, the first one is about is comfortable or not. So lots of the head-mount display, they are really heavy. So if you have a look with the HoloLens, they are heavy, and then you feel that it's not comfortable for the user to wear and then handle it. Okay, and then the first one, of course, you need to care is the whether the user feel comfortable or not. So there are lots of the solutions in the world, and we'll talk about this kind of product later in our slide. Okay, or you also need to think whether I should have the wow or wireless. Okay, wireless solutions. So try to imagine you are not a robot, right? So you are not connected with an electricity prop. You are not Eva. Okay, you are not the robot in the Japanese comics or cartoon animations, right? So if you are connected with a wire, so it's not comfortable to do it. Okay, so we'll discuss the situation in our later slide. Another one you need to think about is about the amount of data. So as we have mentioned before, of course, it's good to capture all the data of your whole body, okay? But somehow the more channel that you need to capture, the more data you need to process, and then you need potentially increase your computation power to do it. So yeah, it's good, but it's not really realistic to handle this kind of things, okay? The third one is about the realistic. So you need lots of the people to do the 3D modeling, and then you need to handle the graphics, you need to handle the physics to present a good realistic environment to your user. Sometimes you also need to deal with the real object, okay, and also the virtual scenes, okay, the virtual object. So for example, I want the user to touch the physical chair, and then I can match the physical chair with other virtual content. Okay, so some of the people that are doing such kind of application or such kinds of development is quite interesting to handle it. So yeah, you also need to think that it's possible to deal with the physical content with the virtual environment.